Okay, 6.7 definite integrals. Okay, remember, the derivative of capital F of x is little f of x. The antiderivative of f of x is capital F of x. So far, when we've been calculating an integral or an antiderivative, we've been using a graph to calculate the area, or we've been finding the derivative of the antiderivative, which cancels out. Now we're going to do it ourselves. Okay, let me write f prime of x equals f of x. Okay, so let's start with the first derivative we found in the shortcut way, which was the power rule. Okay, so imagine you have f of x equals x to the n. The power rule said, right, we brought down the n, x, and then we lowered this by 1 degree. Okay, so what do? We multiplied by the power, and then we subtracted the exponent, or the power, by 1. Okay, we want to go backwards. We want to find the antiderivative. So if I'm given f prime of x, I want to go back and figure out what the antiderivative is. So we're going to do this backwards. So if this is the derivative, how do I go back and find the original function? Well, I know I subtracted the power by 1, so I'm going to add 1 to the power. I'm going to use capital F of x to show the antiderivative. So this is going to be x to the n plus 1. And then I had multiplied by the power when I took the derivative. So now I want to divide by the new power, which is really the power on the original function before I took the derivative. So I'm going to divide by n plus 1. Okay, or you could write this as 1 over n plus 1, x to the n plus 1. Okay, let's try it with actual numbers so we can see what we're doing. Okay, this is little f of x. They want me to find capital F of x, so they want me to find the antiderivative, or this is the derivative. What was the original function is what I'm trying to figure out. Okay, I'm going to use capital F of x to show antiderivative. Okay, so if I want the antiderivative, I'm going to add 1 to the power. So instead of x squared, I'm going to make this x to the third. I'm going to divide by the new power. So my new power is 3, so I'm going to divide by 3. Okay, now let me look at this and see if this makes sense. If I take the derivative of this, I bring down the 3, and it cancels with this, and then I lower it to x squared. So this matches with this. Now, what if there had been some like constant here? I'm going to put plus c here, and then we're going to look at it and see why. Okay, if I take the derivative of this, I get this. Now, if I take the derivative of some constant, I get 0. So I don't know, there might have been a number added here. That might have been a 5, a 4, a negative 11. Since we don't know the exact function that this originally is, we put c here because there could have been some constant added that I don't know about. Okay, and I'm also going to rewrite this with a fraction. This also could be 1/3 x to the third plus c. They're the same. It's whichever way you want to write it, that's fine. Okay, let's try the next one. Oh, for the next one, they're telling me f of x equals 5x to the third plus 6 over x to the third minus 1. I'm going to rewrite this exponential form, just like when we did power rule. Plus 6x to the negative third minus 1. Okay, let me find the antiderivative. Then I'm going to go back and check it by doing the power rule. Okay, so I'm going to add 1 to the power, divide by the new power. So if I add 1 to the power, that is x to the fourth. I'm going to divide by the new power, which is a 4. All right, let me go to the next one. I'm going to add 1 to the power. So this was negative 3. I'm going to make it negative 2. I'm going to divide by the new power, which is negative 2. Okay, now what about the 1? I want to add 1 to the power, but there's no power here. So this is x to the 0. If I add 1, I have x to the 1. So this is going to be minus 1 x to the 1. And then I should divide by 1, although it doesn't really matter when you divide by 1. Okay, I am going to simplify this, but since this is an antiderivative, there could be some constant at the end that I don't know about, because when I take the derivative of that, it goes to 0. So this is, let me rewrite this as a nicer answer. So this is going to be 5/4 x to the 4th minus 3x to the negative 2. So let's make this minus 3 over x to the 2 minus 1x. Actually, let's just make it minus x. And then plus c, because there might be a constant at the end. And then I'm going to go ahead and just check in my brain that this, if I take the derivative of this, I end up back at the answer I started with. So I bring down the 4's cancel, 5x to the 3rd. What is this, 3x to the negative 2? So negative 2 times negative 3 is positive 6, and then I lower this to negative 3, I get this. The derivative of negative x is negative 1, and the derivative of a constant is 0. So this is matching. Okay, let's try C. Okay, f of x, I want the antiderivative, capital F of x. Okay, what I'm going to do, add 1 to the power. Divide by the new power. Okay, minus 6x to the 1. Okay, I'm going to add 1 to the power, so that's squared. Divide by the new power. Plus 3, what is this? This is x to the 0 because there's no x to the 0. So this is 3x to the 1. Divide by 1. Would I really write that out? Not really. Let me add a constant, because when I take the derivative, if there was a constant there, I have no idea when I'm only looking at the derivative. Okay, and then let me just stare at it to make sure it's correct. If I bring down the 3, it cancels, and I lower this to squared. So 5x squared minus 6x plus 3, derivative of a constant is 0. Okay, now one with radicals. I'm going to rewrite it in exponential form, because this will be x to the 1/2 plus 3x to the negative 1/2. Okay, antiderivative. Okay, I'm going to add 1 to the exponent. So 1/2 plus 1 is 1/2 plus 2/2. So now I have x to the 3/2. And then I want to divide it by 2/3. No, I want to divide it by 3/2. Hold up. I want to divide it by 3/2. So if I'm dividing by 3/2, that's the same as timesing by 2/3. So I'm going to make it 2/3 to make it easier on myself. Okay, let me look at the next exponent. I have 3x to the negative 1/2. I'm going to raise this by add 1 to the power. So negative 1/2 plus 1 is negative 1/2 plus 2/2. That's going to make it positive 1/2. 3x to the positive 1/2, and I'm going to divide by the new power, which is 1/2, which I might want to do in my head, but I'm not going to. Okay, you could do that in your head eventually. Okay, let's rewrite this. This is 2/3 x to the 3/2. It's okay the way it is. You could also do it as the square root of x to the 3rd. If I do 3 divided by 1/2, that's the same as 3 times 2 over 1. So this is going to be plus 6. X to the 1/2 is the square root of x. Oh, and you know what? I forgot the constant. Okay, put a C here. Okay, I could double check this. Let me double check. If I do 3/2 times 2/3, that cancels out to 1. I lower this to x to the 1/2. 1/2 here, 1/2s cancel, 3x to the negative 1/2. The derivative of a constant is 0, which is why it doesn't show up on the original f of x function. Okay, that was using the power rule to find the antiderivative. Let's look at integrals of sine and cosine, which you can kind of figure out on your own probably by thinking about it backwards. So I'm thinking, what function gives me a derivative of sine? So it has something to do with cosine. But the derivative, here, I'm going to write cosine here to start with and then adjust it. The derivative of cosine is negative sine. So it's not quite a match. It's off by a negative sign. So let me make this a negative. If I do the derivative of negative cosine is negative sine times a negative turns it into a sine, which means the integral of sine, or the antiderivative of sine x dx, is negative cosine x. But there could be a constant here still, because the derivative of a constant is 0. Okay, antiderivative of cosine x dx. What function, when I take the derivative, I get cosine? Sine x. Derivative of sine is cosine. I'm going to add a constant because the derivative of a constant is 0, and so I don't know what the constant is or if there was a constant there. Okay, now let's look at the fundamental theorem of calculus. Okay, this is saying if f is continuous on the interval, closed interval a to b, then the area under the curve of f from a to b can be represented by, okay, this is the same expression we learned previously. It's the area under the curve from a to b with the x-axis. Okay, now that we know how to find antiderivatives, if I do the integral of f of x dx, it makes sense that that would be the antiderivative, which is capital F of x. But I want to go from a to b. So to show I'm only calculating the curve from a to b, I'm going to put a line, and I'm going from a to b. Okay, now how do I calculate the area under the curve from a to b? I'm going to do capital F of b minus capital F of a. Okay, so let me look again. So if I want the integral of f of x dx from a to b, I find the antiderivative from a to b, and then I do f of the upper bound minus capital F of the lower bound. And that's going to give me the area curve from a to b. Okay, I'm going to draw a picture, but don't draw this picture, okay? Here's some random curve, okay? Let's make this, oh, this is terrible. This is b, let's call this a. Okay, if I do f of b, capital F of b, I'm finding the area of the curve all the way to here. It's like b and everything below it. I don't want everything below it though. I only want from a to b. So if I calculate capital F of a, I'm finding the area of the curve from the left all the way to a, which is all the way from here and then backwards like this. Here. Okay, so if I do capital F of b minus capital F of b a, I'm doing the entire area under the curve from b to the left. If I subtract off capital F of a, I'm subtracting the area under the curve from at x equals a from the left, and I'm going to be left with the area under the curve only from a to b. That's why we subtract the capital F of the upper limit minus the lower limit. Okay, let's try it. Okay, so for example 2, evaluate the definite integral. Okay, we call this definite because there's definite values, there's numeric answers here. Okay, now we know how to find the antiderivative, so we're going to do this algebraically. Okay, so I want to find the antiderivative of 4 minus 6x. Okay, the antiderivative of 4 is 4x minus, for 6x, I'm going to raise it a degree, so now it's 6x squared, and I'm going to divide it by the new power, which is 2. Let me rewrite this as negative 3x squared. Okay, let me check in my head. If I do the derivative of 4x, I get 4. If I do the derivative of negative 3x squared, I get negative 6x. That's a match. I am not going to write plus c because this is a definite integral and I'm going to plug in values. I will show you why in a second why I don't need to write c. Okay, so that's the antiderivative and I'm calculating it from negative 2 to 5. Okay, so let me plug 5 in first. So 4 times 5 is 20, minus 3 times 25 minus 75. And I'm going to subtract capital F of the lower bound. So 4 times negative 2 is negative 8. Negative 2 squared is 4, so negative 3 times 4 is negative 12. Okay, now before I move on, let me think about this for a second. I did not write the plus c here. The reason I didn't need to write the plus c is because if I have a plus c here, and I also have a plus c here, it ends up being c minus c, and it's going to cancel out anyways. So I'm not even going to bother writing it since it's going to cancel out no matter what every single time because I'm doing the antiderivative of the upper limit minus the antiderivative of the lower limit. Okay, let me go ahead and evaluate this. 20 minus 75 is negative 55 minus negative 8 minus 12 plus 20, which is negative 35. And now that you know how to evaluate definite integrals on your calculator, you could also plug this into your calculator to confirm your answer. Okay, let's look at another one. Okay, integral from 1 to 4 of root x minus 1 over x squared. Should I rewrite this? I'm going to rewrite this exponentially. So let's do it from 4 to 1. I'm just going to write this as x to the 1/2 minus x to the -2. You might skip that step eventually, but for now, we're going to do it as we're learning antiderivatives. Okay, so I'm going to take the antiderivative of x to the 1/2. So I'm going to raise it a degree. So now it's x to the 3/2. And I'm going to divide it by 3/2, which really means I am multiplying by 2/3. Okay, let me go to this one. I'm going to raise this a degree. So now it's x to the -1. And I'm going to divide it by the new power. So I'm going to do -1 divided by -1, which is going to make this a positive. Okay, that's my antiderivative. I'm not going to put the plus c just because it's going to cancel out anyways. And I'm going to evaluate this from 1 to 4. Okay, so let's plug in 4. Okay, so what is this? X to the 3/2, so I'm doing the square root of 4 and then to the 3rd power plus x to the -1 is 1/x, so make this 1/4. Minus, now let me plug in 1. 2/3, 1 to the 3/2 is just 1, so let me leave it as 2/3. And then 1 to the -1 is 1/x, so 1/1, which is just 1. Okay, what is this? This is 2/3 times the square root of 4 is 2. 2 cubed is 8. Minus 2/3 minus 1. What is 2/3 plus 1? 5/3 minus 5/3. 16/3 plus 1/4 minus 5/3. What am I going to do with this? Times 4. So what is that? 64 plus 3 is 67 minus 20, 47/12. Okay, so I found that the integral from 1 to 4 of that function was 47/12. And again, you could check on your calculator now that you know how to work your calculator. Okay, let's try the next one. Okay, I want the integral from 0 to pi/2 of 4 sine x dx. Okay, let me take the antiderivative of 4 sine x. The antiderivative of sine is negative cosine. So this is going to be -4 cosine of x. And from 0 to pi/2. Let me double check though. If I do the derivative of cosine, it's negative sine times -4 is positive 4 sine x. I did not put the c because this is a definite integral, and the c's are going to end up canceling out anyways. Okay, so let's evaluate this. -4 cosine of pi/2 minus -4 cosine of 0, which is the cosine of pi/2 is 0. The cosine of 0 is 1, so -4 times 1 is -4, so 0 plus 4, which is 4. Okay, one more example. And they're going to give me information and see what I can do with it. Okay, they're telling me f prime of x is x squared minus 2. They're telling me f of 1 equals 2. Find f of 3. Okay, let me think about this. Okay, they're giving me f prime of x, which means if I found the integral of this, that would kind of correspond to this information, which means this is kind of like the area under the curve. Okay, so let me think about, this is kind of like the example from the other section. So if I want f of 3, they give me f of 1. So let me start with that. Okay. If they give me f of 1, I now want the area above the f prime curve from 1 to 3 to fill in the blanks. of f prime of x dx. So this is going to give me the area under this f prime curve from 1 to 3. If I add it to the part from 1, I'm going to get everything, all the area under the curve up to 3. Okay, now f of 1 is 2. It's given to me. From 1 to 3, f prime is x squared minus 2 dx. So I need to do the antiderivative. Okay, so x squared, I'm going to raise it a degree. So it's x to the third. I'm going to divide it by 3, so I'm going to put 1/3. Minus, this is going to be 2x, and I'm going to evaluate it from 1 to 3. Let me double check. Let me bring down the 3. That's going to be 1x squared. That works. Derivative of this is 2. I'm not writing the c because it's definite integral. Okay, so 1/3 of 3 cubed is 27. Minus 2 times 3 is 6. And I'm going to subtract 1/3 of 1 minus 2 times 1, minus 2. And that is 9 minus 6, which is 3. 1/3 minus 2 is going to be negative 1 2/3, which is negative 5/3. Now let's leave it negative 1/3 plus 2, because that's easier. 4 plus 3 is 7. Minus 1/3. So 21/3 minus 1/3 is going to be 20/3.